Hello friends, welcome to our channel. Here we are going to look at problem 3584, maximum product of first and last elements of a subsequence. In this video, we are going to solve this problem using a sliding window or using linear scan. So our algorithm will have time complexity O n, where n is the length of the given array nums, and the space will be O1. So first, let's look at the problem statement. It's very short. So we are given an integer array called nums and an integer m. So we want to return the maximum product of the first and the last element of any or all possible subsequences of nums of set m. So here there are three examples. You can actually this first one is very special because m equals 1. When m equals 1, so the first and last element coincide. So you just find the largest product of itself. It's corresponding to two squares, right? So this gives you 81. So this is the first example. Well, for the second example, so the output is 20. So you can have, see, for example, this one, 5, -4, and then you can pick any in between, right? So here, the output is not 30. The reason is that you cannot use this two, 5 and 6, because if you use 5, 6, so the index of these two numbers, the difference is just 1. You cannot use them as the start and end because there is no elements in between. So if you want to use -5 and 6, so this is a valid one, but it's giving you -30, right? So similarly, you can analyze problem example 3. So let's also look at the constraints. First, the length is bounded above by 10 to the power 5. So this gives us the problem size, because this problem size can be very large because the length can be as long as 10 to the power 5. The second one is also important. Basically, it says that the numbers or elements in the list can be negative. So this negative thing makes them slightly makes the problem harder. So the m is greater than or equal to 1, less than or equal to the length of nums. This is the consistency assumption. So with that said, I think we are ready to explain the idea and the algorithm. So you will see the code actually is very short. First, we should notice that the element in the nums list is can be negative. So here I change this, I use a or nums interchangeably. So here's a problem reduction. So in a subsequence of set m, we only care about the first and the last elements. So the middle m minus 2 elements can be any elements between them, as long as the order is preserved. So this order, because it's subsequence. So for any pair ij, so what's the criterion for ij can be served as the first and last element in a subsequence of length m? We need that there in between them there are at least m minus 2 elements, right? So this is the condition. So j minus I plus 1, this is the length of this from I to j. It should be at least m. So then we can pick nums I as the first and nums j as the last, and that form a valid subsequence of m. Therefore, the problem reduces to we want to find the maximum value of nums I times nums j for all ij pairs such that j minus I plus 1 is greater than or equal to m, right? So for this problem, actually, we can fix the last one and then find the valid first one. But because the element in A can be negative, in each of the iteration step, we store the largest element possible and the smallest possible because of sometimes two very small negative number gives you a large positive number, right? So the algorithm will be the following. For each index I, we want to find the max possible nums start times nums I, right? Then we're taking max over all I will yield the final return. So we can initialize the maximum first and min first to be the first element in the given list. And then we initialize the result to be negative float infinity because we want to take a maximum, so we use this initialization. Then what we want to do, so for I in range m minus 1, so this is the beginning that I can be served as the end or the last element, right? Then we update the maximum first, so it will be the current state and then I minus m plus 1. In other words, so if we look at this as a whole, so overall the max first, so min first will actually, for each I, we will take the max and the min as long as the elements are far from the current index, how far, to the extent that it can serve as the first element. Then the result will be updated as this: max the pre-state, and then the last element times the max first, the last element times min first. The reason we have 3 items here is due to the fact that the element can be negative. And then we return the result. So this will be the full algorithm. So actually, to write the code, we just need to translate this algorithm into code formats. So here, let's do it. First, the result is float infinity, so put a negative. So then we can max first equals num 0, right? You can write 1 line, but I will use 2 line. Min first will be num 0, right? Then what we want to do is a for loop for I in range m minus 1, ending at length nums. So maximum first will be updated like this: max, so the pre-state, and nums I minus m plus 1, right? So why minus m plus 1? Because if you set this index supposed to be x, then I minus that x plus 1 should be the length, should be greater than or equal to m. Therefore, x should be less than or equal to I plus 1, then minus m. That's this number, right? So if you look at it in a whole cascading fashion, so this will catch this x, right? So same for min first. It will be min first, and nums I minus m plus 1, right? Then the result will be max the pre-state, and then nums I times max first, nums I times min first. Then finally, we just need to return the result state. So this is the full code. So let's see. Yeah, it passes the 3 test cases. So now let's look at the generic case. Yeah, it passes all the cases. So needless to say, so the time complexity will be O of n, and it's the length of the nums, and the space complexity, so it introduces several variables like max first, min first, this is the intermediate one, and the result, so it's O1. So if you want to know more information about this, so you can do some print. Print, so I, the current state, and the result state. That's going to be result. And current I, let's also print out the nums I. Entering step, right? So now let's also print out exiting, right? So let's print empty line. Now let's see. So in the first one, so ending at I equals 0, so maximum possible is 1. Ending at here, just 81. As I mentioned, this corresponds to do square, right? So now let's look at the case 2. So case 2, the return is 20, right? So it's ending at step 5, right? So this one. So the largest will be this one, right? So if you at step 4, the largest is 18. So this one, it will be multiplied with 3, right? So similarly, you can look at example 3. So for example 3, 35. So ending at index this one. So the multiplication will be this one, 5, 7, right? So with that said, I guess that's about it for the current video. Thank you for